So softening of water. What is softening of water, students? Softening of water. What is softening of water? Students.
The removal of hardness, like
Remove
hardness causing salts.
Removing hardness causing salts present in the
Water.
Okay. So that is called softening of water. The process where we remove the or reduce the hardness of water. Okay. So that process we are following two treatment methods here. So one is external treatment. So other one is internal treatment. Okay. So what is internal treatment, ma? What is internal treatment, students? What is internal treatment?
Using chemicals.
Using chemicals. So we will add directly chemicals into water. Okay. And we will reduce the hardness, or we will remove the hardness. We will add chemicals directly into the water. Okay. So there are here we discussed that. So when we are using the water, when we are using chemicals in water, so either precipitation takes place or complex formation. Complex formation, that is complex compound formation in the water, or precipitation. Okay. So the treatment of water includes in internal treatment either by precipitation or by complex formation. And next, in external treatment also, either precipitation takes place or complex formation, or by complex formation. But most of the time in internal treatment only we will observe that complex formation. In external treatment, so we'll get completely soft water without any precipitation, or we get the precipitation. So there are two types of treatment methods, ma. One is external treatment, one is internal treatment. So why we have to go for softening of water means because we are using the water for domestic purpose and industrial purpose. For domestic purpose and industrial purpose, we are using the water. So in domestic purpose, we use for water for washing, cooking, okay, bathing. So we need water. So we have to use the moderate hard water. Completely soft water we won't use, but we can use the moderate hard water. So in industrial purpose, so mainly we are discussing, ma, that is you can see the students here. Okay, we are using water in boilers. We are using water in boilers for steam production. So that steam we are using to generate the electricity. Okay. So we are getting the problems in boilers. When we are using hard water, we are getting the problems in boilers. So to avoid that problems, okay, we are discussing that here two types of treatment methods, that is external treatment, internal treatment. Okay. So we are not discussing internal treatment, ma. We have only external treatment. Okay. In that external treatment also, we are going to discuss ion exchange process. So students, what is external treatment? Students, what is external treatment, ma? You forgot?
Zeolite, ion exchange, like limestone soda thing, and zeolite.
No, external treatment means what? What we do before using the water in boiler, we are going for what is external treatment?
First, to remove the hardness of water outside.
First on the outside.
Through physical methods, and then add water. Then we keep it in the boilers.
This is the outside process, ma. So we remove the hard salts present in the water, means nothing but we convert the hard water into soft water. So then we use that soft water in the boilers. We use that soft water in the boiler. So this is the external treatment. External treatment means nothing but we are removing the hard salts present in water before using in the boiler. Before using in the boiler. So it is known as external treatment of water. So the treatment is given to water for removal of hardness causing salts before it is taken into the boiler. Before it is taken into the boiler is called external treatment of water. So this treatment prevents the boiler problems. Okay, we won't get any problems in boilers because if we are using hard water, we are getting the problems like we'll get a boiler corrosion, and we'll get some precipitation formation in the boilers. Okay, and we'll get scale and sludge, nothing but a precipitation formation around the walls of the boiler. So we can reduce or we can avoid these problems, okay, by using soft water in the boiler. So that soft water, what we are doing, how we get the soft water? So we are removing hard salts present in the water. So before using it in boiler, so that treatment is called external treatment. So what are the examples are there? What are the methods are there in external treatment is lime soda process, zeolite process, ion exchange process. Okay, there are 3 methods are there in external treatment, but we are going to discuss only one method, ion exchange process. Okay, so lime soda process, already we have taken example in permanent hardness, in types of hardness. So that when we used sodium carbonate in water, that chemical sodium carbonate in water, so that converts into a, so reacting of sodium carbonate with the salt, hard salt present in water, either calcium or magnesium in water, and converting into a calcium carbonate, which is insoluble precipitate. Okay, so this is one example we have taken, and one more example is ion exchange process. So today we are going to discuss ion exchange process. Okay, so this is one method where we can get the soft water, where we can go for external treatment, that is nothing but converting a hard water into soft water or removing hard salts present in water. So internal treatment means, I think everybody knows. So this, we will add chemicals directly in the boiler feed water. In the boiler water, directly we will add chemicals so that we can remove the hardness present in the water. So there are some examples are there, some methods are there: colloidal conditioning, phosphate conditioning, calgon conditioning, and carbonate conditioning. So just to know the methods and examples, I gave this one. Okay, but you can concentrate on external treatment of water. So here one topic, ion exchange process in external treatment of water. So what is ion exchange? What is ion exchange means? So ion exchange, it is a process by which ions held on a porous, especially insoluble solid are exchanged for ions in solution that is brought in contact with it. So we are taking here a insoluble solid. Insoluble solids means we'll take the polymers. We'll take the polymers with a porous structure. So having a functional group, either H plus ion or OH minus ions. So these, when we are using as ion exchangers, so where exchanging of ions taking place from the solution, nothing but from sample of water, the exchanging of Ca2 plus ions or Mg2 plus ions, for example, it is exchanged with the what we are taking the solids here, a porous structures having functional groups H plus. So that H plus ions are exchanged with the calcium Ca2 plus ions. Okay, when we are using hard water containing calcium or magnesium with this ion exchange resins. So ion exchange resins. What is ion exchange resin? What is ion exchange resin? Resin means that are polymers. We are using polymers, which are solids that are porous structures. Okay, having a porous structure, and the functional group either will take H plus and OH minus ions. So what is ion exchange resin means? Ion exchange resins are insoluble. They are insoluble, cross-linked, high molecular weight organic polymers. So they are cross-linked, high molecular weight organic polymers with a porous structure, and the functional groups attached to the chains are responsible for the ion exchange properties. So they have the property of exchanging of ions. Okay, the ions present in the ion exchange resin, or it will exchange with the ions that is either cations and anions present in the water sample. Okay, so what is ion exchange resin means? These are insoluble, cross-linked, high molecular weight organic polymers with a porous structure, and the functional groups attached to the chains are responsible for the ion exchange properties. So there are two types of ion exchange resins. Okay, so one is cation exchange resin, the other one is anion exchange resin. So cation exchangers, exchange resins, what we are taking here is, so you can see here, we are taking styrene divinyl benzene copolymers. Styrene divinyl benzene copolymers containing the functional group, either carboxylic group or sulfonate group. Okay, so this we will use as a cation exchange resin. So these cation exchange resins are capable of exchanging their H plus ions with the cations of the dissolved salts. Okay, what are the cations present in the hard water or a sample of water means calcium and magnesium ions present in the water. So these H plus ions, the cation exchangers which are having H plus ions that are exchanged with the Ca2 plus ions and Mg2 plus ions which are present in the sample of water. So the cation exchangers, we are representing the by a general formula RH. We will represent with the RH. Okay. So R is the general structure of the resin and H is exchangeable with the cation. Exchangeable with the cation. Which cation? The cation which is present in the sample of water. So this is cation exchange resin and the anion exchange resin. So we will use anion exchange resins. These are styrene divinyl benzene copolymers. Styrene divinyl benzene copolymers. So you can see the structure here. Already we have written in the notes. I gave you how to write the cation exchange resin and anion exchange resin. So okay, anion exchange resins are styrene divinyl benzene copolymers containing the functional groups. What is the functional group? Here OH minus ion. OH minus ions. Okay, containing the functional groups, that is phenol formaldehyde or amine formaldehyde. Phenol formaldehyde or amine formaldehyde. So they which exchange their OH minus ion with any anion present in the dissolved salt. So what are the anions present in the dissolved salts means? For example, chlorides, sulfates, nitrates. So all these anions that is exchanged with the OH minus ions present in the here what we are taking anion exchange resin. So what is anion exchange resin means? Styrene divinyl benzene copolymers. Okay, having a functional group with the OH minus ion. So the anion exchangers are also represented with the general formula ROH minus. Okay, so R is the representation of the general structure of the resin and OH is exchangeable with the N. So all this we discussed in the class, students. Just I am repeating. Okay, na? So thus all the cations and the anions present in the dissolved salts are exchanged with the cation exchanger resin and anion exchanger resin. So what are all the cations present in the water and the anions present in the water? So that nothing but dissolved salts that will be exchanged with the cation exchanger resin and anion exchanger resin. Okay, students, are you listening to the class?
Yes,
Students are
ma'am.
listening to the class?
Yes, ma'am.
Tell me what is cation exchange resin? What is cation exchange resin? What is cation exchange resin? Students, already you wrote in the notes.
Styrene divinyl benzene copolymers
Styrene divinyl.
containing functional group sulfide
Sulfonate group or carboxylic group.
Sulfonate or carboxylic group.
Carboxylic group. What is anion exchange resin? What is anion exchange resin? Anion exchangers are
Styrene divinyl benzene copolymers.
styrene divinyl benzene copolymers containing the functional groups.
Phenyl formaldehyde and amine
or
formaldehyde.
amine formaldehyde. Okay. So now you know the students what are the ion exchange resins we are using, cation exchange resin and anion exchange resin. Okay, we'll discuss the process now. So this diagram you have to take in your notebook. Okay, this diagram you have to take in your notebook. After my explanation, you can take the diagram. Okay. Now listen everybody. So we are taking two chambers here, two chambers. So in first chamber, we are taking cation exchange resin, and you can see after the below that cation exchanger bed, we arranged a gravels layer for the support of the cation exchange resin. We are arranging gravels layer. Okay. So there are two layers are there. So first layer is cation exchange layer. Second layer is gravels layer. Okay, gravel bit. So in second chamber also we arranged here. So the first layer anion exchange resin and second layer a gravels bed. Okay. So for the support of anion exchange resin, so we are arranging gravels bed. Now next you can see in the first chamber there are two inlets are there. There are two inlets in first chamber. So one inlet you can see here where we take the hard water. Okay, one inlet we will take the hard water, and the second inlet. Okay, so what we are, for what purpose we arranged here, one pipe we connected here to this chamber. So we have arranged in one container. In one container we have arranged here acid solution. So for regeneration of the cation exchange resin, so we have arranged acid solution. So we will take here either hydrochloric acid or sulfuric acid, HCl or H2SO4 we will take in the container. Okay. So next we can see in the first chamber there is one outlet is there. Okay, where we can pass it outside, any wastage. Okay, will pass through the sink. Okay. So next here to the first chamber we are giving connection to the next chamber with one long pipe. We are connecting. We are giving connection to the first chamber to the second chamber, where we arranged here pressure pump also, where we can allow the water. We can pass the water from first chamber to second chamber. Here also two inlets are there. First inlet where we have given connection to the pipe. So we pass the water from first chamber to second chamber. Okay. So the other inlet you can see where we arranged in the container, that is right side, we arranged in container alkaline solution for regeneration of resin, anion exchange resin. So we have arranged here sodium hydroxide solution. Okay. Next we can see one outlet here, the second chamber. So where we can pass the wastages to the sink. Through this sink we can pass the wastages outside. And for this, in the second chamber we have given one outlet here. Okay, one more outlet here. Two inlets are there and one outlet for wastage to sink. So one more outlet to collect the soft water. So this is a ion exchange diagram. Okay, so what we arranged here. So you have to draw exactly in the exam this diagram as it is. You have to draw. So we'll discuss the process now. So first we are taking a hard water. Okay, cation exchange process. Now what we are doing is, so we'll take the hard water. So we'll sprinkle on the cation exchange resin, so that here we can see the exchange of the Ca2 plus ions which are present in the water, that are exchanged with the H plus ions in the cation exchange resin. So what we are getting here, what we wrote here, 2RH plus CaCl2. CaCl2 means that is present in hard water, students. That is present in hard water. Now the Ca2 plus are exchanged with H plus. So what we wrote here in the reaction, R2Ca plus 2HCl. So the collected water is containing HCl. The collected water is acidic water. Okay, that is containing HCl. So if magnesium is present in hard water, magnesium chloride, for example, present in hard water. So the magnesium Mg2 plus ions that are exchanged with H plus ions, that is in the cation exchange resin. So where we can write here R2Mg plus 2HCl. Okay. So the collected water here from first chamber, it is containing HCl. So that is more acidic water. Okay. So the hard water is passed through the cation exchange column where all the cations like calcium and magnesium are removed from it, and the equivalent amount of H plus ions are released from this column to water. So I gave two more examples here. That is the water containing calcium sulfate, okay, and a magnesium sulfate. So where here also the Ca2 plus are exchanged with the H plus ions, okay, present in the cation exchange resin. So we wrote here that is R2Ca plus H2SO4, means the water is containing, okay, H2SO4, acidic. The water is acidic here, H2SO4. Okay. So here after complete, okay, means we are using hard water from cation exchange resin. Then we take this water and we'll pass it. We'll allow this water into second chamber. So through the pipe, okay, already we arranged a long pipe here, okay, and we use the pump here. We will allow the water to the second chamber. Okay. So here exchanging of anions will be taking place here in anion exchange process. So the water is passed through then the water is passed through the anion exchange column where the anions present in the water. Anions present in the water. What are the anions present in the water? We have seen previously, okay, that water is containing HCl, means what is present? Chloride ions are present. And next we can see here what is present, H2SO4, nothing but sulfate ions are present in the water, means anions are present in the water. Okay, so when this water is passed through the anion exchange column, so the sulfate and chloride ions present in water are exchanged with the OH minus ions present in the anion exchange resin. Okay, so now the anion exchange resin, it is completely how it is converted. It is converted into RCl or R2SO4. Okay, we can write the reactions here, ma. ROH, that is anion exchange resin, plus, so what we passed water from first chamber to second chamber, second chamber. So the water is containing HCl, the water is containing H2SO4. Okay, now here the water containing HCl, nothing but containing H plus ions and chloride ions. So that chloride ions are exchanged with the OH minus ions, So where we can write the reaction here, that is RCl plus H2. Okay, so completely we are getting solved, okay, from ion exchange process. So you can collect here. So after passing through the anion exchange resin, after complete removal of anions present in the hard water, so you can collect the soft. You can collect the soft water from the second chamber. So we can take one more example also here. So where the water containing H2SO4 solution, okay, sulfuric acid, okay, ma. So where exchange of sulfate ions with OH minus ions, that is present in anion exchange resin. So we can write the reaction here, R2SO4, that is there in anion exchange resin, plus 2H2 plus 2H2O. So the water coming out from exchanger is free from all ions. Free from all ions means free from all cations and anions present in the hard water. So it is called deionized water. It is called this method is also known as deionization method or deionized water. That water is called deionized water or demineralized water. Demineralized water. Okay, ma. So this is the process where in ion exchange process, that is exchanging of cations with cations present with the H plus ions of the cation exchange resin, and exchanging of anions present in the water are exchanged with the OH minus ions present in the anion exchange resin. So students, now you know the process form. Okay, very simple process. Okay, where we arranged cation exchanger bed, anion exchanger bed, and exchanging of both cations and anions is taking place. Okay, by passing through cation exchanger bed and anion exchanger bed, and what we collected the water completely, it is completely soft water without any hard salts, So in industry, you can see, okay, ion exchanger, that equipment you can see in industries. Now, after doing for about 10 hours, or 8 to 10 hours, the cation exchanger bed completely, it is covered with the calcium and magnesium salt. Completely, it is covered with the calcium and magnesium salt. And anion exchanger bed, it is completely covered with the sulfate, chlorides, or nitrates. So we cannot do the process properly here. We cannot go for purification of the water properly. So we have to go for regeneration. So regeneration, what we are doing here, we are arranging two solutions here. You can see in the diagram. Okay. So to the left side, you can see in one container, we have taken acid solution, HCl solution. So in the right side, you can see one more container. We have taken a sodium hydroxide solution. So we'll go for regeneration. So what we do in regeneration is, okay, so the cation and anion exchangers, okay, it is completely, it comes under exhausted position, means we cannot go for purification process. So we go for regeneration so that we pass the dilute HCl. Okay, we will use the dilute HCl. So we will pass the dilute HCl or dilute H2SO4 solution into the cation exchanger bed. So that here we can observe here. So the cation exchanger bed, it is completely covered with calcium or magnesium. And when we are passing HCl solution onto the cation exchanger bed, now here the exchange of the H plus ions, okay, it is exchanged with the calcium and magnesium present in the cation exchanger bed or cation exchanger resin. So where you can see here the reaction. So you can regenerate cation exchanger bed. So you can write here 2RH, means exchanging of H plus ions from the solution, that is HCl solution, exchanging of H plus ions with the calcium present in the calcium that is present in the cation exchanger resin. So we can write here 2RH plus CaCl2. So the CaCl2, that is wastage. So we can pass it through the sink. You can see in the diagram. Okay. So one outlet is there. Wastage will pass through the sink. So this is the regeneration of cation exchanger resin. Regeneration of cation exchange resin. Very simple. We are using here. So we are using dilute HCl or dilute H2SO4. These solutions we will use. So this solution, dilute HCl, for example, we will pass through the cation exchanger resin, where exchanging of the cations, okay, it will be taking place H plus ions with the Ca2 plus ions present in the cation exchanger bed. So you can use that fresh cation exchanger resin or bed. You can use for process of purification of the water. So the washings containing calcium chloride or magnesium sulfate, okay, so that were passed to sink or drain. So that is about regeneration of cation exchanger bed or cation exchanger resin. So next one is anion exchanger resin. Anion exchanger resin, we will use sodium hydroxide solution. So sodium hydroxide solution, we are passing through the anion exchanger bed. We are passing through the anion exchanger bed. You can see in the diagram. So we will use the alkaline solution, sodium hydroxide, so containing OH minus ions. So that we are passing through the anion exchanger bed. So what is there in anion exchanger bed now? It is completely covered with chloride ions or sulfate ions. We wrote RCl. Okay, so this is anion exchanger bed. So we are going for regeneration, means we are passing sodium hydroxide solution onto the on the anion exchanger bed, where here also exchanging of anions will be taking place. That is OH minus ions are exchanged with the Cl minus ions. OH minus ions are exchanged with the Cl minus ions. So we can write the reaction here ROH plus NaCl plus NaCl. Okay, ma? So this is now fresh. Okay, means anion exchanger bed you can use for purification of the water. So the exhausted anion exchanger is treated with the dilute NaOH solution. You have to write this reaction. Okay. So what we are getting washings, sodium chloride. So that washings are discarded into sink. You can see in the diagram. Okay. So that I told you students, you have to draw the diagram correctly, neatly. Okay, ma, so that you will get the marks. So the regenerated ion exchanger, okay, that is used for the softening of water. Students, are you there? Students, are you there?
Yes.
What happens when we pass the hard water through cation exchanger bed? What happens when we pass the water through the cation exchanger bed? Tell me. What happens when we pass the water through the cation exchanger bed? Now 4 questions for you. We are passing water. Students, we are passing water through the cation exchanger bed. So what you are removing in? What you are removing, ma, here? Anybody? Students? What is the process, ma, in cation exchanger bed? When we are passing hard water through cation exchanger bed, what happens? Nobody? Students? Dheeraj? What are exchanged, ma, in cation exchanger bed?
Ma'am, calcium and magnesium.
Calcium
Salts.
and magnesium
Salts.
are exchanged with the
RH, ma'am.
are exchanged with the RH. What is present in cation exchanger resin? What is the? Which ions are present in cation exchange resin, ma? Which ions, ma, in cation exchange
H
resin?
plus ion, ma'am.
H plus ions. So H plus ions are exchanged with the Ca2 plus ions. Where it is present?
Hard water.
Hard salts.
Hard water. Ca2 plus ions are present in hard water. So that Ca2 plus ions are exchanged with the
OH.
H plus ions present in the
Cation.
cation exchange resin. Okay. So the water you collected, what it is containing now? You collected water from first chamber. That water is
Cl.
containing. That water is containing what, ma? Negative ions. Okay. So then what we are doing next? We are passing through the anion exchange process. What happens in anion exchange process? What are the anions present in the water, ma? Hard water. Students, what are the anions present in the hard water?
Cl minus SO4 ma'am.
Cl minus and SO4 2 minus ions. So that is exchanged with the, what are the anion present in the anion exchange resin?
OH minus.
OH minus ions. So both are exchanged. OH minus ions are exchanged with the Cl minus ions. Yes or no? Students?
Yes, ma'am.
OH minus ions are exchanged with the Cl minus ions, anions present in the hard water. Okay. So what you collected now? What you collected, ma? After completing the process,
Water.
Water.
from second
Water.
chamber, what you collected? See the diagram, what you collected from the
Soft
second
water.
chamber? Huh?
Soft water.
Soft water. It is completely without any hard
Hardness
salts.
causing
Without
salts.
any hard salts, either cations or anions present in the hard water. It is completely without any hard salts. Okay. Now, so after doing for 10 hours, okay. So what happens to the cation exchanger bed, anion exchanger bed? It comes to the completely exhausting position. Why? The bed is completely covered with calcium and magnesium. Okay, the bed is completely covered with calcium or magnesium. In anion exchanger bed, so that is completely covered with chlorides, sulfates, etc. So we go for regeneration. So what are the solutions we are using for regeneration? Students, what are the solutions we are using for regeneration? Tell me.
Dilute HCl or
Dilute
H2SO
HCl,
or H2SO4.
dilute HCl or dilute H2SO4. For what purpose we are using? Regeneration of
Cationic bed.
cation exchanger bed. Why we are using NaOH? Dilute NaOH, why we are using?
There will be calcium on the anion exchange bed, so we use NaOH so that to regenerate anion.
To regenerate the anion. Okay, so it is compulsory, or we have to do compulsory regeneration of the cation exchanger bed and anion exchanger bed. Then we can go for, again we can use for softening of the water. So this is about ion exchange process. Students, you have to draw the diagram compulsory. So as it is, you have to write the process, cation exchange process, you have to write the reactions, and the anion exchange process also, you have to learn the reactions. What I am giving in the PPT, that is enough. You learn these reactions. Okay. Now, so advantages, advantages, highly acidic or alkaline water can be purified by this process. Highly acidic water or alkaline water, we can that can be purified by this process. And water is containing the soft water what we collected, so that hardness either it will be 0 ppm or 0 to 2 ppm, 0 to 2 ppm. Okay, so most of the time this water we will use in, it is suitable for high pressure boilers. Okay, so these are the advantages of ion exchange process. And disadvantages means this is costly, means chemicals are expensive. Okay, so the ion exchange resins are expensive, cost of the purification is high. Okay, and the water should not contain any clay. Okay, any sand particles, any clay. So the turbidity should be below 10 ppm. Okay, otherwise the resin will be blocked. So because it is porous structure, no, it will be blocked, and output of the process will be reduced. Okay, so tomorrow I will repeat these advantages, disadvantages, and process you have to tell me very clearly tomorrow. Okay, this diagram you take from PPT, I will send you. Okay, na students? Understood, ma? Class.
Okay, ma'am.
Students,
Yes,
everybody understood?
Yes, ma'am.
Yes, ma'am.
Cation exchange process, anion exchange process, regeneration also. Okay? Okay. So shall I end the class?
Attendance.
Attendance.
Attendance, I will take, ma. I will take from Zoom only. Okay, na? No problem.
Okay, ma'am.
Students. Okay.
Thank you, ma'am.
Okay, ma.